Well, this is the final exam review, part 2. We're going to do the last page here. So starting with converting 0.6 radians to degrees. So we can do that by looking at the proportion that says your radians to your degrees is equal to pi over 180. And so we're going to convert by substituting 0.6 for r. And the trick about this is that you cross multiply right here. So that's going to be 0.6 times 180. I think I need a calculator for that. 0.6 times 180 is 108. And then you set that equal to this cross product, or in other words, you just divide that by pi. So if you take 108 and you divide it by pi, you will get 34 point, it doesn't say where to round it, but 34.4 degrees ought to be good enough. Okay, now we're going to go back the other way with 124 degrees. So you're going to take 124 in place of the d, and that's equal to pi over 180. Now the trick here is we don't really multiply by pi. We leave it in terms of pi. So 124 pi, there's the cross product, and you divide by 180. And then mostly what people do is they just reduce the 124 over the 180. Those should both be divisible by 6. Let's see, 124 divided by 6. No, let's see, that didn't work. 124 divided by 4, that ought to work. That's 31. And 180 is divisible by 4, and that's 45. So that most likely would be what you'd see in a multiple choice question. Okay, number 12. With the following question, create a normal distribution curve, label the axis. The average wait time to purchase a new cell phone coming out, or iPhone coming out, is 30 minutes with a standard deviation of 3 minutes. So as we label this, we have 30 in the middle, then 33, 36, 39, go back the other way, 27, 24, 21. And what percentage of people waiting in line for more than 36 minutes? It's a 1, 2, it's at the, actually 0, 1, 2. It's after the second standard deviation. So if you have your flip chart, anything after the second standard deviation looks like 2.5%. That's 2.35 and the 0.15. So 2.5%. If 100 people were in line, how many of them would expect to wait less than 27 minutes? That's less than -1 standard deviation. And if you look at everything less than -1, that would be 16%, or 0.16. But remember, there's 100 people. So the answer is actually 16 people. Okay, and then we have two diagrams. We have a box plot here, and we have this histogram. So describe center shape and spread of Ms. Strickland's math test scores. Okay, so shape. Remember, when you have a small quartile, That's going to be tall. So you have a tall one, and then a not so tall one, and then even not so tall one next to that. So tall, less tall, and even less tall. And this would be about equal on the other side. So if you look at that as a histogram, then a not so tall, a tall, a less tall, and about the same. You got a skew there. The skew is going to the right. This is skew right. When you have skew, you should use median for your center. And the median is this vertical line right here. And so that's at about 75. And that's the median. And the spread, we can use IQR or we can use range. IQR would go from 70, let's get some of this junk out of the way, would go from 70 to 85. The range would go 55 to 100. So either one of those, you'll have to adapt based on the multiple choice, but IQR is, so spread, IQR is 15, and the range was 45. Remember, these are single numbers. They are not intervals in statistics. Okay, now we're going to look at the other one. We're going to look at the histogram. Its center, it's almost symmetric. The center, which could be the mean or the median, is somewhere between 71 to 80, I would say. Probably right in the middle. 71 to 80, or just you could say 75. The shape, it does have a kind of symmetry to it. It does have a big gap. And then also the spread, we could very easily go with the range from about 41 to about 100. So range 41 to 100. Well, we're supposed to put a number, right? So that would be like 59. I know that doesn't look mathematically correct the way I wrote it. So let's just say 59. Which class do you think did better and why? Well, I would say that the class that is in the histogram, this one did better. For one thing, this one on top is skewed right, so the scores are getting smaller, and where the gap is 61 to 70, well, that's over here somewhere, and it's tall from 70 to 75, but the other one, the one here on the bottom, is tall from 71 to 80. So it's kind of hard to tell with that gap there, but I would say that if it wasn't symmetric, you could definitely say this is maybe skewed to the left. More of the data has kind of been pushed to the right. And then over here, more of the data has kind of been pushed to the left. So I would say, and the centers are almost the same. The centers are about 75. So which class do you think did better? I think that's called Mrs. Beck's class. Mrs. Beck, because she has more data above the mean. or above the center. Okay, that'll about do it. We'll see you next time.